I thought it'd be a little fun to go through a LeetCode problem today. Perhaps you're interviewing or get up your chops with programming again, or just getting back into the swing of things, and you want to practice data structures and algorithms. So this morning I came across a fun little one on LeetCode for converting Roman numerals to integer. It was pretty easy, it didn't take very long to do it all. And it was a little bit fun, so I thought we could just walk through this together quickly and see what everybody thinks. By the way, if you like this type of video, do let me know in the comments and maybe I can make more of these. So with that, let's head over to LeetCode and we'll take over the Roman numeral to integer problem. Okay, so this problem is, we'll start this with TypeScript. I guess we could really do anything. I could always do Python or C# or plain JavaScript, but TypeScript is pretty popular in the corporate world. So this problem is essentially converting Roman numerals, which are these symbols that you see here on the left, into their corresponding integer values, and essentially adding these up all together to get the final resulting value. So you can see here a little example, I would convert to 3 since each I is just 1. The only caveat here is if a smaller value is in front of a bigger value, then it actually means that you subtract it from the bigger value. So an example of that is IV. If V is 5, I is 1, since the I is in front of the V, we subtract the I from the V and we get 4. So to start this problem off, think about it. I always like to programming problems like this with the result. So we'll just say result equals 0, return result. That's a really good start to the problem. So at least it starts setting up the form. Now, the next thing that we need to do is, actually we could even say, since this is TypeScript, we'll set result to the type of number. The next step is to define our mapping of the Roman numeral symbols to their integer values. So there's a couple of different ways that you could probably do this. The first one that comes to my mind is just to set up a mapping of symbols using a JavaScript object or hash map, which we can set up like this. So we're going to enter all the values followed by all the Roman numeral symbols followed by their values. So if I, V is 5, we'll have X is 10, we'll have L is 50, C is 100, D is 500, M is 1000. This defines our symbols. I think this looks pretty good. So this is a really good start. And you know, the next thing that we're going to need to do is we do have to take it, actually, if you want to comment, you know, when you're going through technical interviews, it's always a good idea to comment your code and explain how you're coming up with a solution. So we could do something like create a mapping of symbols to their corresponding values. Okay, so the next thing that we want to probably do is we need to take into account a smaller value is in front of a larger one, then subtract it. So the way that we can do that is we're going to need to store the last value that we just read. So we're going to read the string. Why don't we start with that? Let's start with the for loop. Let's say enumerate the symbols, convert to integers, and add up the sum. That's essentially what we're going to do. So we'll start a for loop, right? So I call a number, we're doing TypeScript. We'll start from the right and read to the left. So we'll see number I equals s.length minus 1. We're doing minus 1 because we're looking at the index, not the total length of the string, since we're going to be looking at the characters. So we'll do I equals 1 till I is greater than equal to 0, I minus minus. So this is pretty basic. We're just going to walk through the string character by character. Since we are walking character by character, we can get the symbol that we're currently looking at, like this. We'll just index into s of I. That will give the most symbol. So imagine that we're looking at this problem right here. We're going to grab the I on the farthest right. That will be symbol. Let's convert it to the value now using our map. We can say value number equals, this is pretty simple, symbols of symbol. So this will index into our map, and we're going to get symbol of symbol, which is I, which is going to give us the value of 1. So with the value of 1, we could technically just do something like result plus equals value at this point, which will start adding up those numbers, but that's not actually what we want to do just yet. So here to actually check. We need to check, is this symbol less than the last one that we just read? Because if it is, we're going to subtract it. If it's not, we'll add it. So on that note, we're actually going to need a temporary variable. We need to remember the last value. So we're going to set last value as a number. We'll set it to null. And we'll say store the last symbol that we've read to use for subtracting. Okay, so now that we've done that, we can probably do, now, let's see here. We know that we're going to set the last value to be the value that we just read. So we can say here, update last value. And we also know that we want to add the current value to the result. Now, if we just run it like this, it'll probably pass the first test case and the second test case. I don't think it'll pass the third one, because this is going to end up being one where we need to subtract. So let's just see what happens if we run this. I have a feeling it should pass the first one. Let's see. Yeah, so just as I suspected, the first case this works, right? Because we're not taking into account the negative values yet. The second one works likewise, and the third one because we didn't take into account the IV, or these other ones like, let's see here, CM, yeah, that's another one where a lesser value is in front of a greater one. So now let's take into account this. So what we can do here is, instead of result plus equals value, what we're going to do is we're going to say if the last value is, if the last value is greater than the current value, right, then we don't want to add. If the last value is greater, which means our current value is smaller, we want to subtract value. Otherwise, we want to add the value. So we can probably reword this comment, take into account smaller values in front. And that looks pretty good. Otherwise, add the value to the total. Okay, so I think this should probably work if we run this now. Let's see what this looks like. Okay, so this worked. It passed all 3 test cases now. I think we might be missing something with the null. Let's just take a look just to see. If I were to submit this, let's see if we run into any problems. Oh, okay. So there you go, 68%. So this worked. If you want to take into account that null, I think it's fine, because null will never be greater than a value. But it wouldn't hurt to say, if last value ends, right, is greater than value, just to take into account that null. So this is pretty good. I think if you want to think about this a little, there might be some better ways to solve this problem. This one was pretty straightforward. I think that this works pretty well. The code is legible. You could even refactor this. Like if you wanted to get crazy here, you could convert this into a one-liner. If you want to refactor, you could say result plus equals last value greater than value, then result times -1, which will subtract it. Otherwise, value. Otherwise, just add the value. And if you run it this way, you're going to get the same result. It'll still work. It shouldn't be any faster, but of course, LeetCode, it bounces all over. You know, it's a little bit cleaner if you you convert this into a one-liner, right? I guess that a little more slick. I probably like the original way better. I think it's more legible. It's easier to read, but this is a pretty good example. This was a very quick intro into algorithms. It's sort of like a warm-up exercise. Let me know what everyone thinks about this. If you like this, please leave a comment, subscribe, like the video, and I would be happy to do some more. So with that, I'll see you.